Hi students and friends, this is your host and teacher Sayyid Ayazuddin Haider. You are watching Learn and Teach by AYAZ. I will continue my video session for A levels chemistry, that is 9707, 9701. I was doing paper 22 of Feb March 2023 and I'm done till question number 2. So I will continue from question number 23. Question number 3. Alkenes undergo an addition reaction with a 1:1 mixture of CO and H2 to form aldehydes. Figure 3.1 shows the reaction of propene with a 1:1 mixture of CO and H2. So propene, we have product A, product B, CO and H2 is added. A one-defined addition reaction. It's a reaction in which two or more compounds react to form product, one product. A reaction in which two or more compounds react to form one product. Now for compounds, you can even write molecules. Or even reagents. Number 2, aldehydes A and B are structural isomers. State the type of structural isomerism shown by A and B. You look at the structure, A and B both have same functional group. CHO. CHO is the functional group for aldehyde. So it must be positional isomerism. Positional isomerism is the one which have same molecular formula but different position of the functional group. So you write positional isomerism. Name A. There must be 4 carbon atoms in it. 1, 2, 3, 4. And it's an aldehyde. So you write butanal. It's a butanal. Number 4. The complete reaction of propene with a 1:1 mixture of CO and H2 produces A and B. Only the product mixture contains 96% A and 4% B. Calculate the mass of A produced in this reaction when 5 × 10⁻³ kilogram of propene is used. So according to this figure, according to figure 3.1, 1 mole propene gives 1 mole of A plus 1 mole of B. So what about the molecular formula of propene? It's C3H6. The product we are getting C4H8O. No need to write the formula for other product. It also has same molecular formula. So if you calculate the MR, we need to calculate the MR of C3H6 and C4H8O, and we will express this in kilograms. So for propene, it's 42. So I will write 42 kilogram gives, what about butanol? It's 72. I will write 72 kilogram. Therefore, 5,000 kilogram gives X kilogram. So we'll do the cross. We will get what? X is equal to 72 multiplied by 5,000 and divided by 42. (72 multiplied by 5,000 divided by 42. 8,571. 571.58. 0.4285. 428 kg. Now what I will do, I will calculate the 96% of this, because they are saying in the question it's 96% A. They are getting 96% A. So 96% of A means we'll multiply 96 by 8571.428 divided by 100. So what we will get? The mass must be 8228. 8228.570 kg. This will be the final answer. Moving to next question. B. A and B show reactions typical of aliphatic aldehydes. Number 1, A undergoes a nucleophilic addition reaction with a mixture of HCN and KCN forming compound C. Complete the diagram to show the mechanism for this reaction. Include charges, dipoles, lone pairs of electrons, and curly arrows as appropriate. Draw the structure of the organic intermediate. So we must be getting a CN negative charge and H positive ion from HCN. So we are reacting with HCN. So it must be like this. O, C, H, C3H7. Oxygen being more electronegative will acquire partial negative charge, and carbon acquire partial positive charge. Due to this, CN, cyanide ion, which is electron rich, it's a nucleophile. It will attack the carbon, and this will make the shifting of lone pair of electrons of carbon towards, there's a bond between carbon and oxygen, one of the bond, move towards oxygen. Then we will get what? We will get this. CO will acquire negative charge now. This is negative charge. And we have C3H7 here, H here, and here we have CN. So this negative charge will attract H positive ion. So in the end, we'll get this product, C. Number 2, table 3.1 shows information about 3 experiments involving B. Complete table 3.1. Table 3.1. So experiment 1. What must be the reagent here? We are asking about the reagent here. Solution turned from orange to green. This observation with B. What is B? B is aldehyde. B is aldehyde. Remember, it's an aldehyde. So I will write it here. It's an aldehyde. So I'll write aldehyde. So it must be acidified potassium dichromate. That is K2Cr2O7. So you write acidified K2Cr2O7. Now what gives us silver mirror on the sides of reaction vessel? It must be called Tollene's reagent. What about Br2? There won't be any reaction. So you simply write no reaction with Br2. Moving to next part. Number 3B, C4H8O is oxidized by acidified potassium magnate 7. Complete the equation for this reaction. Use O to represent one atom of oxygen from the oxidizing agent. C4H8O plus O. So once it gets oxidized, there must be addition of one oxygen atom. It's an oxidation reaction, so you will simply write C4H8O2. Number 4, C is chiral molecule. Circle any chiral centers in the structure of C shown in figure 3.2. This figure 3.2. What is chiral molecule? Chiral one which contains 4 different atoms or groups attached to it. So if you look at this, the carbon, it must be having 4 different groups. We have OH group, hydrogen, CN, and this one. The structure must be like this. Let me say chiral. So we have C3H7. C. When propene reacts with CO and an excess of H2, an alkane and a mixture of alcohols are formed. Instead, the alcohols are isomers of each other. Suggest the molecular formula of the alkane and the alcohols that are formed under these conditions. We have propene, so it must be forming propane. The alkane must be propane. What is the molecular formula of propane? So we'll get propane here. C3H8. What about the alcohol? We are getting propanol. Propanol. Formula must be C4. Sorry, C3. H8O. This must be propanol. Sorry, it's a CO here. So you can't have propanol. It must be butanol. It must be butanol. Butanol, 4 carbon atoms. Butanol. So you will get C4H10O. D. The reaction of ethene C2H4 with a 1:1 mixture of CO and H2 is shown in equation 1. Equation 1, C2H4G plus COG plus H2G. Reversible sign, CH3CH2CHOG. At atmospheric pressure, a cobalt-based catalyst is used in this reaction. Number 1, state and explain the effect of using a catalyst on this reaction. It simply increases the rate of reaction. Now, it's 2-mark question. You have to mention the description that's by providing alternative reaction pathway with lower activation energy or EA. So you write increases the rate of reaction. By providing alternative reaction pathway with lower EA. Number 2, explain why the yield of CH3, CH2, CHOG increases when the overall pressure of the reaction mixture is increased. If you look at this equation, let's count the number of moles of gases. On the reactant side, what do you have? 1 plus 1 plus 1, which means it's 3. On the product side, it's 1. So there's a less number of moles on the product side. So definitely, due to this reason, equilibrium shifts to the product or right-hand side. Equilibrium shifts to right hand or product side. It's because of fewer number of moles or molecules or volume of gases on that side. Number 3, use the information in table 3.2 to calculate the enthalpy change delta HR of the reaction in equation 1. Equation 1, C2H4G plus COG plus H2G gives CH3CH2CHOG. Enthalpy change of formation, C2H4 is provided, CO is provided, CH3CH2CHO is also provided. We know that delta H is equal to delta H of the product side minus delta H of the reactant side. So putting the values, the product side, what do you have? We have minus 187, minus, we have minus 111 for CO, plus for C2H4, 52. So the final answer must be minus 128. So 111 must become plus here. So 111 minus 52 becomes minus 52, minus 52, minus 187, minus 128. Moving to the next question. Number 4, the reaction mixture is cooled to collect CH3CH2CHO as a liquid. Identify all types of van der Waals forces that are present between molecules of CH3CH2CHO. It must contains instantaneous dipole, induced dipole, and permanent dipole. Permanent dipole is due to the presence of CHO. So you write instantaneous dipole and induced dipole and permanent dipole. Question number 4. Figure 4.1 shows some reactions of compound D, 2-bromobutane. This is D, 2-bromobutane. So here's the reaction. We have reaction 1, reaction 2. We don't have reaction 3. We have reaction 4, reaction 5. A1. State the reagent and conditions used to form E in reaction 1. In reaction 1, we are getting alkene. It's an alkene. We are getting alkene from bromoalkane. So what will be the condition? We have alcoholic NaOH. So you write alcoholic NaOH. Or you can mention alcohol or ethanol plus NaOH in heat under reflux. Number 2, draw the structure of one repeat unit of the addition polymer that forms from E. What is E? Here is E. It's alkene. It's 1, 2, 3, 4. It's butene. Butene. It's to ene. Removing the double bond, having 2 CH3 in it. So it must be like this. Double bond is removed. This must be the one repeat unit for the addition polymer formed here. Next part. E also forms when F is heated strongly in the presence of an Al2O3 catalyst. Write an equation for this reaction. Here's F. Here's F. It's butane dash to all. So I will write the equation for this. This must be butane C4H10O. Using C4H8. Or you can even write the structure formula. So we'll have CH3, CH, we have OH on the second carbon, then we have C2H5, we have CH3, CH, double bond, CH, CH3. And definitely we will also get water as the other product in this reaction. B1, predict what is observed in reaction 2. We have bromide group and it's reacted with AgNO3 aqueous. It must be creamy white precipitate or off-white precipitate. Creamy white off-white precipitate forms. Number 2, identify the yellow precipitate and the organic ion formed in reaction 3. This is reaction 3. So the reaction 3 is alkaline I2. Yellow precipitate must be of iodo form, and organic ion, it must be propanoate. Propanoate, yes, it must be propanoate. We'll be getting iodoform or CHI3, CHI3 or iodoform. You can also call it triiodomethane. There is a structure. This one is removed and gives yellow with I2 and organic ion. So organic ion must be propanoate. So you can write CH3, CH2, CO2 minus or propanoate. C1. State the type of reaction that occurs in reaction 4. Here is reaction 4. Here is reaction 4. This is reaction 4. So when you are reacting with KCN, what you are getting CN, which means it must be substitution because CN is substituted Br. So you write substitution. Number 2, reaction 5 is similar to the reaction of LiAlH4 with carboxylic acids to form alcohols. Suggest the role of LiAlH4 in reaction 5. So it's definitely acting as a reducing agent. Where's reaction 5? Here's reaction 5. You see it's reducing CN2, 2CH2, NH2. So write reducing agent here. D1, figure 4.2 shows the infrared spectrum of one of the compounds D, E, F, G, or H. Use information from table 4.1 on page 14 to identify which of the compounds D, E, F, G, or H produces the infrared spectrum in figure 4.2. So we have on page 14 figure, we need to consider this table. So for your convenience, what I will do, I will draw the structure of compound from D till H. So D, which D is this Br. E is this. What about F? There's OH. G, there's CN. H, there is CH2 and H2. So these are the functional group we have. Peak for the, we don't have peak for the bromide. We have for alkene. Yes, we have alkene. There's a possibility. Hydroxy. And this one is nitrile. This one is amine. And we must be having of alkanes. We have CH2 here. Alkene, hydroxy, nitrile, amine, alkane. So we have possibility of these. Hydroxy, CO, there's a possibility. What about alkene? Yes, there's a possibility. Nitrile, C triple bond, and yes. Alkane, yes. Amine, yes. Hydroxyl OH, yes. So see the absorptions one by one. For hydroxy, let's start for hydroxy. That is either 1040 till 1300 and 3200, 3600. 1040 till 1300. 1040 till 1300. One hundred, 200, 300. There isn't any peak. So this isn't, this is not there. What about next one? Hydroxy, 3200 till 3600. 3200. This is 200 and 600. We don't see any peak here. Any absorption there, I mean, sorry. So it's also excluded. What about alkene, 1500 till 1680? 1500, this 1500, 1680, between this area. No absorption. So it is also not there. So far, we don't have alkene, we don't have hydroxy. We are left with nitrile, amine, nitrile and amine. Let's see, amine. Amine must be 3300, 3500. 3300 till 3500. Yes. Again, no absorption. So amine is also absent. So it must be nitrile. It must be. Let's see. For nitrile, there must be 2200 and 2250. Absorption must be 2200 till 2250. 200 and 2250. This is the peak for CN. So you write absorption at 2200 till 2250, and it is of C triple bond N. Therefore, it must be G. Number 2, in the mass spectrum of D, the relative abundance of the molecular ion peak is 3.4. Predict the relative abundance of M+2 peak for D. Explain your answer. What is D? D is this. So it must be due to this bromide. Due to bromide. Then you will write 3.4 and relative abundance. So BR, we know that BR 79 dot BR 81, because you know that they are ratio 50, ratio 50, 50 to 50, or you can even write 1:1. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.